Welcome everyone to SQL Friday. This is SQL Friday number 47 and our star today is Thimantha, who is going to talk about Power BI and how to reduce the size of a large model, if I understand the topic correctly. I am not a Power BI specialist at all, but I'm sure Thimantha will give us the whole picture of it. Welcome to SQL Friday, Thimantha. Whenever you're ready, you can just take over and share your screen and start the presentation.
Thank you, Magnus. So I'll share my screen right now.
Yes.
All right, so I'm sharing my screen. I hope it's visible.
It is, yes.
Great. So let's get started. And so good morning, good evening, good afternoon, and good evening to everyone who had joined us from around the world. So this session is about utilizing large-scale semantic models in Power BI service. As Magnus told, this is basically about how you can reduce your model size and basically how you can utilize your semantic model that's published into service. So just a bit about me for anyone if you don't know about me. So I'm Thimantha Vidanagamage. I love working with Microsoft data platform technologies such as Microsoft Power BI, Azure Analysis Services, and Azure Data Factory. So the most important thing out of all the details that you see in the screen right now is my Twitter handle at Thimantha. So please follow me on Twitter at Thimantha. Moving into the agenda for today, firstly, I will take you through some basics of semantic models in Power BI. Later on, we'll look at Power BI datasets as semantic models in service. And finally, I'll be wrapping up this session by showing you how to utilize your own semantic models, large-scale semantic models in Power BI service. So before we move any further, it's important for us to have a basic understanding of semantic models. So a semantic model is a data model that is used for analytical purposes, specifically catering the end users. So end users are usually business users in an organization or company who are basically a part of the analytics. There are two types of semantic models. These are tabular semantic models and multidimensional semantic models. So previously, it was just multidimensional semantic models that were available, and later on, tabular semantic models came up. Also, tabular semantic models are a lot more compressed compared to multidimensional semantic models as well. And in this session, we'll be looking at tabular semantic models because in Microsoft Power BI, you can only develop tabular semantic models. Also, the semantic model follows a basic concept between a fact and a dimension. So a fact is a table with numerical figures, while a dimension is a table which consists of an aspect of looking at a fact. So for example, a fact can be sales and a dimension can be region, and regional sales can be analyzed with the combination of facts and dimensions. So that's just a bit of basics to brush up on semantic models. So let's move into semantic models in Power BI. So this is basically what I'm going to show you now is basically the story of a semantic model in Power BI. Basically, how the semantic model works in a simplified way in Power BI. Firstly, a semantic model will be built in Power BI desktop with reference to a respective data source or multiple data sources. So this data source can be simply anything that you see in the Power BI connector under the Power BI connectors in Get Data. It can be simply anything out of all those connectors that you see there. And after you develop the semantic model in Power BI desktop, the semantic model will be published, or you will publish the semantic model into Power BI service as a Power BI dataset. So the published semantic model will be consumed by multiple reports, which are used for end-user analytical purposes. And just to keep you noted, this is basically the simplified flow of a semantic model, or just a simplified story of a semantic model in Power BI Excel, in Power BI. So yeah, there can be complexities added into this, like the Power BI data flows, and this can be made complicated. But I just wanted to keep this simple as possible so that anyone can actually grab into like what's really going on and what's really happening in a semantic model in Power BI. So that's just a story of a semantic model. And just to keep you noted, so I have told that you in the last step, you see in blue, I have told that the semantic model or the Power BI dataset, which the semantic model which is published as a Power BI dataset, can be consumed by multiple reports, and also it can be consumed. It can just be consumed by business users for self-service BI as well. So that is a part of the basic. That is once again a part of the basic flow of a semantic model in Power BI. So that's just something to keep in mind. Moving further, now we had just brushed up our basics in semantic models, and we had looked at semantic models in Power BI. How does it work in Power BI? And now it's time to understand what this large-scale semantic model is. So a large-scale semantic model in service is a semantic model with a high level of complexity. So what does complexity mean? Complexity could mean several tables, several relationships, complicated relationships, several calculated columns, multiple columns, unnecessary and necessary. So that's what you mean by complexity. Along with that, adds up the model size. So obviously, when you have several tables and several calculated columns, several necessary and unnecessary columns, and multiple complicated relationships, your model size will expand. So your model size will expand. This will end up being a large-scale semantic model. So in this session, what we'll be looking at is how we can utilize these large-scale semantic models that you have in Power BI service. But before we move into that step, it's important for us to keep in mind the restrictions of a semantic model in Power BI service as well. So just to keep in mind, there are two types of licensing that are commonly used in Power BI. So these are the shared capacity licensing, which is the Power BI Pro license, and the dedicated capacity licensing, which is the Power BI Premium license. So with consideration to this, we have maximum and minimum model sizes for the Power BI Premium and Power BI Pro. So for Power BI Pro, the maximum model size of a data set in service, or for Power BI data set in service, is 1 GB. When it comes to Power BI Premium, the maximum model size of a data set in service is 10 GB. And yes, with the large data sets functionality, by enabling that, you can exceed this boundary and you can go further in terms of the model size. So that's just a bit about model sizes and how it's restricted based on the type of licensing you are using in Power BI. And similarly, there are certain restrictions for Power BI dataset refreshers as well. So what are these Power BI dataset refreshers? So Power BI dataset refreshers is where the Power BI semantic model that's published into Power BI service as a Power BI dataset, it accesses the respective data sources that it has been linked to and gets in the latest data into the semantic model. gets in the latest data into the semantic model. So that is what you meant by a refresh in Power BI. Power BI dataset refresh is that is what you mean by a Power BI dataset refresh. What you mean by a Power BI dataset refresh. So these refreshes can be scheduled as per the users of the business users, or as per the requirement of the end users. You can say end users, yeah. And when talking about that, there are restrictions for these scheduled refreshers as well, based on the type of licensing that is used, based on the type of Power BI licensing that is used. So if I just brief you them, so you can go for up to 8 scheduled refreshers per day if you are using a Power BI, if you are going under a Power BI Pro license, and you can go for 48 scheduled refreshers per day if you are going for a premium license. So what does that mean? So you can schedule your refresh for 8 times a day if you are using Power BI Pro. You can schedule the refresh between the data source and the Power BI dataset or the semantic model in Power BI service 8 times a day. 8 times a day if you are using the Pro license. And if you are using the premium license, you can refresh your semantic model or your Power BI dataset that's in Power BI service with the data source 48 times a day. So those are the restrictions. So with all these considerations, with all these factors and considerations, you will have your business users or the end users who will be using the Power BI reports and who will be engaged in self-service BI. So these guys might want to see the data in basically these guys might want to see the latest data. So latest data soon as possible, right? So we have to facilitate that as well. So for that, you might have to, if you are using Pro, you might even utilize all your 8 scheduled refreshes that you can do per day. And if you are using Premium, you can even go for, if there's a requirement for 48 scheduled refreshes per day. But there is a restriction for this. You cannot if your data, for example, you can if your data model is not utilized enough, if you are large scale semantic model or just a it could be a small scale semantic model as well. Basically, if you are large scale semantic model or whatever the semantic model it is, if it's not utilized enough to in terms of model size and in terms of model size, that means you cannot facilitate this, right? So for example, because it affects your refresh time. So for example, just think that you are under Power BI Pro license and you have published a model to Power BI service, a workspace in Power BI service, and that model is around, let's say, 500 MB and 600 MB, I guess. Let's say, around 500 MB, and your business users want to see the data every hour in their 8 working hours. So which means you have to utilize all your 8 scheduled refreshes that you are given. You have to utilize with that privilege, and you have to manage with that. But since your model size is large, your model size might not refresh within an hour. Basically, for such a scenario to work, where you have 8 scheduled refreshes per day and a refresh every working hour, that means your model should refresh under 1 hour every time, right? you cannot really facilitate that. If you can't facilitate that, if your model can't refresh, uh, if your model can't refresh under 1 hour, that means there will be a problem, right? If your model gets 1.5 hours to refresh, that means it will overlap with the next scheduled refresh and there will be massive issues with that. So it's important for you to utilize your semantic model much as possible and facilitate your semantic models much as possible for the end users to see the latest data if there is a requirement like that. And if your end user just wants to see a T-1 data, yes, you don't have a problem with that. You will not have a problem with that. This problem exists with clients or with business users who want frequent refreshes or who wants to see latest data soon as possible in their reports or in their semantic models for Power BI for self-service BI. So you, with these restrictions, with these privileges or restrictions and everything, you have to manage these large-scale semantic models. So you have to keep these restrictions in mind if you are when you are utilizing your large-scale semantic model. So that's why I brought you. I just got some time and just explained you this scenario, like the problems we can have and the restrictions we have and the problems we have to face with that. So that's something to really keep in mind, the restrictions. So now we have a proper context of what we are, proper idea of what we are trying to do and what we are trying to solve. I think we have a very good context in terms of that. So let's go, it's time to look at the demos. So before moving into the demos, I realized that it's important for you to understand the requirement. It is definitely important to understand the requirements that I'm working around with these demos. So why I'm saying that, if you don't get these requirements and the requirements that I have used for the demos, you might not get like what I'm trying to do with that and what's the purpose of that. So I had built two scenarios in two user stories. So I think if for the technical folks here, I think you might be familiar with user stories, but if there's anyone who is not familiar with user stories, just keep in mind that user stories are simple descriptions that are used to define the requirement from the end user's point of view, right? Basically, define the requirement from the person who gives you the requirement, which is the end user's point of view. So that's just about it, about your user stories. So I have structured both my requirements in these stories which I will be showing you, and you will get a clearer understanding of what we are trying to do with this when you look at these requirements. So without talking any further about this, let's quickly look at our user stories. So we have two user stories from two teams. One team is the reseller sales team. So let's see what they are saying. So as the reseller sales team, I want to analyze reseller sales by date, product, reseller, and sales territory so that I can take data-driven business decisions in terms of reseller sales. So that is coming from the reseller sales team, who just want some analytics and who want some analytics to just help them with their daily process, help them with the decision making in their daily process. And the next requirement is coming from the internet sales team. So as the internet sales team, let's say as the internet sales team, I want to analyze internet sales by date, product, customer, and sales territory so that I can take data-driven business decisions in terms of internet sales. So once again, this is something the internet sales team wants some analytics to take their daily to take daily business decisions in their process as with the reseller sales team. But these are two different processes. So two different teams with two different intentions and two different points of view. So these are basically two different requirements. So keeping these requirements in mind, let's jump into our very first demo today, which is model restructuring. So I would not just explain about this. So I'll jump into my demos and talk to you about what model restructuring is. So based on the two requirements that we discussed previously, we have two different requirements. One is from the reseller sales team and the internet sales team, as I told you previously. So these are two different requirements, right? But their requirements are not that, seem to be slightly similar. But you might think that all these requirements might fit in to your respective, you might think that both these requirements might fit into a single semantic model, and you might structure your semantic model as it is shown in the single semantic model. So I'll show you that single semantic model that I have developed with both these requirements taken into account. So I have, I'm sorry, this is not the model that I wanted to show you. So I'll quickly open that model. Sorry for the inconvenience caused. So Power BI semantic, just to talk about Power BI semantic models, I think they are one of the most important aspects that everyone should know in terms of Power BI, and specifically utilizing that as well, because with the functionalities that are given in Power BI, even us as BI consultants, we face different types of problems and different types of issues. So with the new functionalities that are available, which are coming in from the clients. So I think it's important, utilizing large-scale semantic models is one of those problems that we have worked upon. So so it's important for you to keep in mind about this semantic models and utilizing that, especially if you are a BI consultant or BI developer or someone anyone who is working with Power BI, because your end user or your business user might come up with different types of problems for you to solve with these new functionalities and features available. So that's something to keep in mind, and we have our model ready now. So I have, as I told you previously, for both these requirements, I have facilitated both these requirements in a single semantic model. So if to get you guys a clearer view about this, I'll go into the ER view. We call it the model view. So in that you can see I have facilitated both these requirements, because both these requirements are from a single domain, and it's just these are basically you can call it subdomains, which are coming under, basically sales is the main domain, and under sales you have reseller sales and internet sales. So both these requirements are similar. So I have put these two requirements together in a single semantic model, and you can see these requirements fulfilled with the dimensions and also the fact tables, reseller sales and internet sales as per the requirement. So I had facilitated that. So talking about that a bit, do you think this is the right way to do it? Actually, it's not. This is not how you should coordinate with your requirements. You shouldn't clutter your requirements, all your requirements, even though they are in the same domain, into a single semantic model. You can't do that. Like, just think you have like 4 or 5 requirements coming in from different types of end users who have different intentions. You utilizing, trying to fit in all these requirements and cluttering in all these requirements into a single semantic model is definitely not the right way to go about this. With this, you will lead into the same issue, which is the large scale, which is the problem in utilizing a large scale semantic model. So if you guys already have a model like this, with all the requirements cluttered into a single semantic model, it's time for you to split this. You need to split this into separate requirements. So a single semantic model, you should maintain a discipline in terms of a semantic model. Like a single semantic model, you should maintain around 1 or 2 or maximum 3 fact tables. You can't go above that. You can't have 5 or 6 fact tables catering different types of requirements in a single semantic model. This will increase the model size, and you will face issues with the refresh time, and you will have to face issues with this. So the right way to coordinate such a requirement or to handle such a requirement is to split these 2 requirements into 2 separate semantic models. So I had done that in 2 separate models, and I have opened that. So one is the internet sales requirement data model, which I have here. You can see it's just a data model with a single fact table, and you have the required dimensions around it. You have product, you have customer, territory, and the common date dimension or the calendar dimension. So that is your internet sales. That's how you coordinate, or that's how you facilitate the internet sales requirement. And let's look at the reseller sales requirement. It's similarly done as well. So that is also in a separate data model. So I'll show you that. That is also in a separate data model, a separate Power BI desktop file as well. That is also a separate semantic model in a separate Power BI desktop file. So if I just go into the model view on that, once again, you can see it's just one fact table, and I have a broken relationship. So that so I'll fix that to order key to date key. All right. Okay. So this is my fact table. This is how I have facilitated the reseller sales requirement. So the reseller sales requirement once again has just single fact tables and the dimension tables surrounding this respective fact table. So that's how you do it. You have to split the requirements into separate semantic models so that the semantic models will be a lot more simpler, and you will not have problems in terms of model size and refresh times as well. So it's always good to split it and keep it so that those kind of problems can be avoided easily. So even if you don't, even if you don't do any kind of actions or the any kind of strategies, which I'll be telling you in the next few demos. Even if you don't do those, and if you just do this, your semantic model, you will not have problems with the Power BI dataset refreshes or your large-scale semantic models. Simply, you might not even have something called a large-scale semantic model because you had split up a semantic model with multiple requirements into separate semantic models, and they are handled separately. So that is a really good way. That is something that you should really consider even in your existing semantic models. You might have existing semantic models as I showed you previously called a semantic model, and you might have 8 to 10 fact tables in that. And that's not really the right way. And definitely, you might, if your data load is large as well, definitely you might be having problems uh, in terms of model size or refresh time or anything like that. Maybe the refresh time is taking too long. Maybe the model size is growing rapidly. So you definitely might be having problems like that if you have a fact table, if you have a single semantic model like the sales semantic model with around 8 to 10 fact tables catering for different requirements. So this is a really good way to overcome that, and it's really important for you guys to consider this. This is like the go-to thing, go-to step that you should consider in terms of your model structure, in terms of how you should coordinate your models and how you should split your models. So that is about model restructuring for you. So we had gone through model restructuring. Now it's time for us to have a look at the data flows. So what are data flows? Data flows is a component that's available in Power BI, where you can do data preparation and data transformations, and also where you can consolidate your entities or your master data tables as per the requirement for self-service BI or as required for your semantic models. So if I just jump now I just gave you a brief just a brief understanding on what data flows are, but when I'm actually working on it, you will get an understanding of that. So if I just jump into our user stories, our requirements quickly. So we have two requirements, and both these requirements kind of have similar dimensions or similar ways in aspects in which they want to see internet sales and reseller sales. For example, so the internet sales guys, the internet sales team wants to see internet sales by territory, product, and date. And if you just have a look at the this is reseller sales. So reseller sales wants to look at reseller sales by territory, product, and date, as you can see here, and reseller. And if you have look at the internet sales, so the internet sales guys, they want to look at territory, product, and date as well. And they have a dimension that the reseller sales guys don't want to see, which is customer. So just to brief you, this is just an example scenario. So in the real life, this might not be the case. Reseller sales guys might want to see the customer dimension as well, but just to build in with this scenario, I just have done certain manipulations for you guys to easily understand what I'm talking about. And so as you can see, the reseller internet sales team, these guys want to see the internet sales by product, date, territory, and customer. And if, as I showed you previously for the reseller sales guys, they want to see reseller sales by date, product, territory, which are same as the internet sales, and they want to see by reseller as well. So they are kind of, what they want to look at are kind of similar, right? So that means when your semantic models are published, as you will see here, right? When your semantic models are published as Power BI datasets, as you can see here, these semantic models might have repeating logic in them. So what do I mean by repeating logic? So for example, if you take, sorry, I'm in the wrong semantic model once again. If you take reseller sales, the model will have to be, the model will have the same logic for territory in reseller sales and the same logic will exist for territory in internet search. So we have repeating logics at this stage. That is not really a great way to go about things, right? You have repeating power query, you have repeating logic in for transformations in these two semantic models. This is just a waste of time, and this is a waste of time in terms of your refresh time. So you are doing the same thing twice, which is not really a great way to go about this. And so it's not really a great approach. So what you can do is, instead of repeating these logics or repeating this power query to cater the same requirement in two different semantic models, cater the same necessity in the requirement in two different semantic models, you can actually use data flows and just run that logic once, just use or execute that refresh logic once, execute that power query once, and have output tables, and use those output tables as reference to your Power BI semantic models or Power BI datasets. So that your logic will only execute once and will be referred by the respective your logic in your respective tables will only be executed once, and it will be referred by multiple semantic models as per their requirement, so that there will be no any repetitions and stuff like that, right? So that's basically why we need to use data flows for this purpose. You can save a lot of refresh time by just using data flows, but by using data flows. Only thing is, before executing your refreshes in your Power BI datasets, you should run a scheduled run refresh for your data flows first prior to your Power BI semantic model refreshes. So what that will do is it will first what will happen actually is that firstly the data flows will be executed referring to the respective sources, and it will run the Power Query logic and keep your data claims transformed and ready and prepared to be used in the semantic model. And afterwards, your semantic model refresh will execute, where it will refer the output tables of those data flows, and it will use that for their semantic model, for the semantic model, and basically there will be no repeating logic. It will not access the data source multiple times just to refresh the data, because the data is already brought in, cleansed, transformed, and is ready to go as output tables in data flows, right? So that is the reason why you use data flows. So let's quickly look at these data flows. If I just take you through the data flows, so I had created a single data flow called dimensions, and let's just see what it looks like. So as you can see, I have brought in all the dimensions in this data flow. You have the product dimension, date dimension, customer, territory, and reseller. So all my dimensions are brought in here. So if I just want to see how the logic and the backend stuff looks like, I can click on edit tables. And as with Power BI desktop, you will go into your respective Power Query view, where you have all the functionalities in Power Query that you can use, and you can simply do your transformations and stuff here. So I have built my respective logics. I have my logics maintained here in Power Query. Cleansing, transformation, everything's happening here, as you can see, for the respective dimensions. So that is how the data flows that I have created look like. So what if you want to create a new data flow? So I'll take you to that process real soon. So I'll just cancel this, and to create a new data flow, you need to click on Add Tables, Firstly, you need to access your respective data flow. Mine its dimensions. Firstly, you need to access that, and you will see your output tables here, which are your dimensions you have brought in. So you will see the tables option right at the right hand side top of your screen, and just click on that. And afterwards, you will be directed into a screen where you can select the data source in which you need to bring in your data and do the data preparation with. So for that, my data source is AdventureWorks DW 2017 data warehouse, which I have placed it in Azure SQL database. Just for me is so what I'll do is I'll go to the actual SQL database connection, and I will enter my server name here. So I'll provide my server, and I hope there are no IP address issues. Let's see how it goes. And I will just type out my 17 database name. Who is it? Adventure. Maybe I'll just not enter a database name and go on with this. So as you can see, my credentials are already saved, encrypted and saved, because I had used the same credentials for the same server previously, just for my other development. So I have that saved. I don't need to retype that or anything. So I'll go to next. And if you go into next, you can see all my respective databases. Two of them are data warehouses, and just one of them is a database that I have placed in Azure SQL database for my easy access. So what I'll be using for this is AdventureWorks DW. So I will be using that, and maybe I'll just take in a table just to show you guys. So just looking at what can I bring in, looking at something simple so that you can get a clear understanding without any complexities. Let's see. Okay, I guess I'll take sales reason. Okay, I'll go for geography for the moment, I guess. Let's see what it looks like. Okay, I think this is okay for now. So it's a dimension called organization. So small table, so it's easy for me and easier for you to understand as well. So I'll just click on transform, and I should have my table there. Sorry, I did a mistake there. That's I did not select the. Sorry about that. I did not select the. I did not tick on or select the table that I want to go for. So I'll quickly get you through this process. Sorry for the inconvenience. So I have my details here, and click on next, and I have access. And once again, I'll jump in and look at team organization. So I made sure it's ticked, and I'll click on transform. And there you go. You have your dimension brought in, and I just want to make it look a bit user friendly. So I would remove the team and call it dimension itself. Let's see what do we want. So let's just keep things simple. I just want my organization name and organization key for the moment, and the rest are really unnecessary for me. So what I'll do is I'll click on this. I'll just take off these unnecessary tables, unnecessary references as well from this dimension. So I had selected the unnecessary columns or the unnecessary attributes, and I would right click and click on remove columns. All right. Okay, this is unnecessary as well, so I'll remove that. There you go. So I have a very simple dimension right now, and I'll click on save and close, and it would just validate your schema, and you will have your output table ready right now. There you go. Organization output table is ready. So what you should be doing is, now at the moment you will see the schema of organization, but you will not see data in this data flow or the output table in this data flow, because you haven't run the executed a refresh with the new output table that you have brought in, with the new Power Query that you have brought in. So you will need to refresh this, and you will see the data from the data source in the data flows itself. So I'll not be going for the refresh level since it's pretty time consuming. So I'll stop it from there, and now I'll show you how we can access it from Power BI data set or Power BI semantic model and bring this organization dimension in. So for this purpose, just for as an example, I'll be using the internet sales model that I had developed, and all I'll be doing is clicking on the get data option that you see. I think everyone knows that, and click on Power BI data flows. And once I do that, okay, sorry for the inconvenience here. I think I have just logged in from another another user account, but let me see if I can fix that to you soon. So yeah, I'll just log in from my respective account. So sign in from another user account, and I'll be typing in my email, and it should be good. Let's see how it goes. Okay, so my credentials are getting saved. So the data set, the login that I previously logged in was a mistake. It was a mistake from it was related to another client project that I was working on. I wasn't able to log in back to my account, so I had logged in back to my account here, and we shouldn't have a problem right now. So let's go to get data once again and go to Power BI data flows. And they ask for your organization account here, and I'll be dropping in my credentials and clicking on connect. Hope this would work out. Right, I think we're good. Yeah, so we are good. And so for this demo, I have been using the demo workspace. You can see here. So as you can see the demo workspace in the Power BI data flows here, since I have a data flow there. So if you have a workspace with the data flow, that will come up right here. So I'll be using that, and I'll be clicking on dimensions data flow, and there you can see the organization data flow. So I'll click on that. As I told you previously, it's blank at the moment, and I'll load it straight up. I don't need to do any transformations because I had handled out everything in the data flow level, so I don't need to go through the same process all over again. So yeah, that's how you bring in output table from data flow into your Power BI dataset. And if you have, you will see the table here, and if you have relationships and mappings, you can do that, and sometimes it's automatically the relationships are created as well. Since this is just an example, I don't really have a relationship, so that's kind of isolated. So this is just a demo for you to show you guys how you should go through this process. So yeah, that's what I really wanted to show you about data flows. And that leads us to our final demo today, aggregations. Okay, just to give you a brief about aggregations. So aggregations basically where you aggregate or you add up your data with the use of a respective aggregation function, where you add up the data to a specific level, right? For example, you might have if I give you a very wait a minute. So without doing much talking about it, I think it would be easier for you to understand if I just demo this out to you guys. So let's quickly jump into the demo. So just keep in mind aggregations are basically adding up or basically yeah, getting your data up to a certain level, so a certain level of granularity, uh, basically getting your values or numerical figures up to a certain level of granularity. So this reduces model size, and depending on how you use aggregations, it can reduce the refresh time as well. So there are three types of aggregation, three ways you can do aggregations in Power BI. So the very first way is that you can use if you are using kind of a database kind of thing, beside a data source like a database, you can have aggregate and maintain your data or maintain your applications as views in the respective database. uh, and the other option is that you can directly once again, if it's something like a database, a data source like a database, you can directly query with SQL and get the aggregations in for your analytical purpose. Get the aggregations in for your analytical purposes with the SQL query directly itself from Power BI. And the third option is with the use of Power Query. You can basically bring in the full dataset to Power with the connector, full table with the connector, and use Power Query and do the aggregations. But this will only be positive, or this will only positively influence the model size, and it would not do any change. It would not have a positivity on the refresh time, because you bring in the full data set and afterwards you do the transformations with Power Query. It's not like you directly bring in the aggregated data set, right? You don't bring in the you don't bring in the aggregated data. You bring in the data set and then you aggregate it. So that's just a bit of a time. That's just consuming. That's consuming a lot of that might be consuming some refresh time. So but definitely we'll have to go for that option if you are using something like CSV files, SharePoint folders, SharePoint files, and stuff like that. You will definitely have to go with something like that, because you can't create views in SharePoint, and definitely because you will have to. It's just tables that you will be dealing with, and you can't use SQL with SharePoint or CSV files or anything like that. So you will definitely have to go for that, but at least using Power Query applications will at least reduce your model size, right? So yeah, that's it. So I'll quickly jump into the demo. Firstly, I just want to show you guys a dataset that I have, right? So I just wanted to show the impact of aggregations. So the first thing I'll be doing is I'll just be getting you through a very simple select all condition. Yeah, so I have a very simple select all here. So what I'll be doing is I'll be querying this out. All right. So as you can see, I had just filtered out currency 100 because I just currency 100 means US dollars. For this example, I thought of just using US dollars. So I had just filtered that out, and you can see 33,400 rows here. And next one, I have a query with aggregations, SQL query. So I'll be pasting that here. So this is the query with aggregations. You can see I have just aggregated data I have aggregated the order quantity and the sales amount for the order date level, because that's the level of data I just want to see for this particular day. I just want to see for this particular day, like how many sales and how many and what's the quantity that had passed through. So for that, I'll be using that, and I have the currency key 100 here as well. So I'll just query that out and show the effect. So we have 33,400 rows, mind you. So once I go with the applications, it reduced drastically for 1,083 rows. So if you bring this full data set, you are refreshing 33,400 rows in Power BI, Power BI dataset, in the Power BI dataset. But if you just go with this, you are bringing only 1,083 rows in. That's a massive difference, right? Obviously, in terms of model size, and depending on where you use, the refresh times will be affected as well, positive. So that's the effect of aggregations for you. So I hope you got an understanding on aggregations. So what I'll be doing now is I have 1,083 rows here. I'll be copying this query, and I'll be just for the demo purposes, I'll be using the internet sales data model, and I'll be going into my usual Azure SQL database, Azure SQL, and virtual XGW. So I would go into Azure SQL database, connect, and I just need to give you my server details here. We have almost run out of time, so I'll just quickly get you through the process. So I just want to enter my table name here, HW, and what I'll do is I'll go to advanced options, and I would just enter my query here. So I'll Control C and get it there, and click on OK. Okay, so I have a bit of issue in terms of credentials. Let's see what we can do about that. I would just enter my password and name, and let's just quickly get through this, and I hope this works out. Okay, seems like let me just try to add my IP again. I hope it works out quickly. Okay, done. And I'll click on that. Seems like an authentication issue. So basically what will happen is, if you have a proper connection here, you will be able to see your data set in transform data, and you can basically use your data set from there itself. Yeah, that's about it for the SQL applications and how you can use it. Sorry about the inconvenience that I caused here. Once again, whether this works out, and if it does, I hope I can really show you guys something. Okay, so it's getting a bit of time. Seems like it's working out. So no. So yeah, so just having an authentication problem here. So that's why I can't pass through this. So that's really the problem there. But yeah, that's what it is when it comes to SQL aggregations, and also Power Query aggregation. You have Power Query aggregations. So I'll be just going into the transform data view and showing you the Power Query aggregations. And in Power Query applications, I'll just use internet sales. I think I have an issue with the connectivity here, so I'll just leave that aside for now, and I'll just show you how you can do Power Query aggregation. So how you do it is, for this example, I'll just use get cells. I'll be using the group by option in Power Query, and with the group by option, you can simply enter the columns that you want to aggregate with, go to the advanced view and just set the columns you want to aggregate with, and then enter your column name and type of aggregation, with it count sum, and just enter the referred column. And there you will have the aggregations in Power BI itself with the use of Power Query. So that kind of concludes my session for today, and there are other techniques that you guys can look into as well. These are for utilizing your semantic model. These are incremental refresh, removing unnecessary columns, role-playing dimensions, and stuff like that. These things you can, and also composite models, which means that the combination of the use of import and direct query mode. So these stuff you can really look into. These are just additional options. What I have covered in this session are the core options that you can go ahead with, and you can really see some results out of that. And these options are some stuff you can try out as well. These would definitely work out as well. So yeah, that kind of concludes my session. And if you guys have any questions, you can ask me right now. Or you can always connect with me on LinkedIn, and I would be happy to help you guys out. And please just use the QR code and just provide some feedback on the session, whether you liked it or whether there are certain areas I should be improving, and whether I didn't do good. You can simply say anything, and I am more than happy to accept that and to improve myself further. I just need to be a good contributor for this community and to contribute you guys better with your feedback. So thank you very much, Magnus, for this opportunity. I have been really waiting for this, and I really loved sharing my this session with you guys, and I hope so everyone got something out of this session. And if you guys have any questions, please feel free to drop in LinkedIn and just drop me a message, and I would be happy to help you guys.
Thank you, Thimantha.
Thank you.
So I am looking in the chat. I don't see any questions. So I think that is it. I see Pranam is writing something now. He says great session. So yeah, thank you so much for coming to SQL Friday, Thimantha. And for those of you who are still here, please do use the QR code to do the rating. It really helps speakers to, emphasize the things that was good and to improve on things that were improvable, so to say. So please do use the QR code provided. I'm heading off for work. I guess, is the working day over for you now, Thimantha?
Not really. So I'll have to just put in some more files because I have got in an hour for this. But I'm happy to do that. I mean, I love contributing for the SQL Friday, and I really loved it. And thank you very much for this opportunity. And looking forward to contributing for this community further with you. And thank you very much, Magnus.
Yeah, thanks. But so have a nice rest of the day and have a nice weekend. I am signing off now, stopping the recording. So, but thank you, Thimantha, and call for speakers for the next season of SQL Friday is coming up soon. I will publish it on callfordataspeakers.com, so feel free to submit another session for the next season.
Sure.
Thanks.
Yeah,
thanks
thank
for
you
today.
very much. Thank you. Have a great day. Thank you.
Bye.
Bye.